Hey guys, today I'm going to show you everything you need to know about breadboards, also known as protoboard or solderless board. Breadboards are used to test prototype circuits. You can make easy circuits to start learning electronics, or you can test more difficult and complex circuits. Make sure you stick until the end for a bonus tip.
This is a breadboard. It's a rectangular piece of plastic used to build prototype circuits. There are several types of breadboards. This is the most common one. It has 830 tie points. You can find medium breadboards, which are half of the big ones, with 400 tie points each. And this is a mini breadboard, which has 170 tie points. So, the name breadboard literally comes from the board used to cut bread. In the early days, people would use wooden boards with nails or screws to make electronic connections. You can use a power supply to feed the circuit, but not everyone has access to one of these. Another solution is to use an Arduino by connecting the 5 volts to the plus sign of the breadboard and the ground to the minus sign. This is not the best solution because if you happen to make a short circuit, it can damage your Arduino board. My personal favorite solution is to use a 9-volt battery using a snap cap to connect it to the breadboard. If you short circuit, the battery will heat up, but it most likely won't damage anything. You can use hookup wires to do the connections, but I don't think it's the best solution because they are weak and can sometimes fail to connect to the breadboard. You can use jumper wires. Connections are way more reliable, but when you are building more complex circuits, it can get very confusing because of the length and amount of wires. Or you can use pre-cut wires, which are my personal favorite. You can find a link in the description below. They make your life a lot easier and will make your circuits look a lot more clean. You can easily insert leads of an LED or electronic component into the holes. It's strong enough to hold the component and at the same time weak enough to release it once you want to retrieve it or put it in a new location. It's also called protoboard or solderless board because this is where you test prototypes before soldering the circuit together. If you want to change something or make a mistake, you can easily change the layout of your circuit. If you remove the back layer, you will find a sticky side that you can glue to anything you like. Strip the breadboards back and you will find the metal strips that are inside the breadboard. These metal strips are responsible for making both mechanical and electrical connections of components you insert in the breadboard. This is why it's also called a solderless board. It allows you to bond electronic components together without any soldering action. Hey, if you're getting value from this, smash the like button and hit subscribe to the channel. As you can see, holes A1 to E1 represent the metal strip. They are not connected to the metal strip F1 to J1. They are also not connected to any holes in the second line. This is the intersection C5, for example. Here you can see all the existing connections in a breadboard. This is the positive power bus rail. Next to it, we have the ground power bus. The longest LED lead is the positive, while the shortest is the ground. This is a simple LED resistor circuit. It will still work if you change holes within the same metal strip. Here you can see the exact same circuit but with a different geometry. Positive wire to the resistor, which is connected to the positive LED lead, and then to ground. Now I am showing you the first circuit again, but this time with two LEDs in parallel. And now you can see both LEDs connected in series. This is the first circuit with a push button. And now we have two push buttons and two or more LEDs. You might have been wondering why is there a big split in the board. This is the only way you can connect a dip in your prototype circuit. You need a separation between the parallel rows, otherwise it would be shorted. Sometimes a medium breadboard is not enough to test our prototype circuits. If you have two of these, you can transform it into a big breadboard by bridging one to another with staples. In my opinion, the most adequate wires to build prototype circuits are pre-cut wires. These wires are useful all the way up from beginners to professionals because they guarantee stable connections and make the circuit cleaner. If you wish to take up electronics and start building your own circuits, I recommend purchasing a breadboard kit which comes with a lot of materials. Pre-cut wires are an essential material. If you want, you can also use hookup wires or jumper wires. My favorite power supply is a 9-volt battery connected to the circuit through a snap cap. If you are interested, you can find a link to these materials in the description. My favorite tools are the wire cutter, needle nose pliers and tweezers. Use the wire cutter to cut any electronic component legs. Doing so reduces the odds of disconnecting components unintentionally and grants a more stable connection. Then use the needle nose plier to give the desired shape, usually 90 degrees, to fit in the breadboard holes. Use tweezers to insert the legs into the breadboard holes with higher precision. Imagine you want to connect the negative power bus rail to hole G45. To estimate the length needed for this connection, measure the distance between the power bus and the hole with the wire and then add 3 extra holes. Cut it, strip the wire's edges and ply its tips 90 degrees to insert in the breadboard holes. When you install a component in the wrong row, it forms an open circuit where electricity doesn't flow. This is where the LED should be connected in order to close the circuit. Sometimes you don't push the wires deep enough in the breadboard, originating a weak connection or, in some cases, no connection at all. Make sure you correctly insert leads into the breadboard to avoid this error. LEDs have polarity. The longer LED is positive and has to be connected to the plus power bus rail. The shorter leg is negative and needs to be connected to the black wire. On the other hand, the resistor does not have polarity, so you can connect it the way you wish. If you connect the positive and negative wire to the same strip, you are creating a short circuit. The battery gets very hot and you can notice a weird smell. This just happened to me. I got distracted, the positive and negative wires of the snap cap touch each other and shorted the battery. The battery is very hot and you can even see that the wire's insulation melted. Using strangled wires in a breadboard can be a nightmare. If you really want to use these wires, solder both tips so it's easier to insert in the breadboard holes.